So my name is Michael Ludden. I run a team of product managers at IBM called Watson Developer Labs, and as part of that, we have an initiative called AR/VR Labs. I have been, what can I say, bugging SVVR, or I've known them for a little over a year. We met at VR LA, a conference in LA, which you may be familiar with, when we were showcasing the first version of a product that we produced for VR developers, focusing on interactive speech interfaces. That's called the IBM Speech Sandbox. I'll touch on it in a bit. But that's kind of my interest here, and that was my gateway drug to making a big VR push for the company and kind of unintentionally becoming an expert on voice interaction in VR. Very niche thing, but I think that it's going to be less niche soon. So today I wanted to do a fun talk around AI in VR, because obviously I work for IBM Watson AI, and I've been doing a lot of thinking around the current and upcoming intersection between the fields of artificial intelligence, machine learning, and virtual reality and augmented reality. So here's the agenda. We're going to talk about terminology because I think this doesn't get defined enough. Don't mind some of the ugly slides. I'll talk over them and make them look great or sound great. So yeah, AI terminology. There's a lot of people that throw around different words that really just make my OCD go nuts, and so I just wanted to, as almost a community service, throw this out there so that people can get a little more crisp on what they're talking about when they say AI. And then I'll touch on some trends for this year that I've noticed, and a little bit of light prediction there, and then some really trippy predictions about long-term trends towards the end if we have time. And if not, we'll just have to, I don't know, smoke a hookah later and talk about it. And Q&A if we have time. I'll try to be quick. Okay, so AI terminology. I'm assuming you guys know about VR terminology, so I don't need to define that and make this a totally idiot-proof talk. But for those of you who may not have had that much exposure in, I guess, the emerging field of artificial intelligence, the word artificial intelligence itself is actually a bit of a misnomer, in my opinion. And it actually refers to the third word down there, which is general AI. When people think of artificial intelligence, they think of movies where a machine speaks like a human and understands stuff and can basically do anything, usually in these movies better than us and with an intent to kill us, right? At least in American movies. But it doesn't have to be that way. There's optimistic versions of the future where AI augments our intelligence and helps us, but I digress. So general AI is AI that can learn a specific task, yes, like let's say playing chess, which is an example that's relevant to IBM. We did the Deep Blue thing in the 90s versus Kasparov, the chess champion, and the computer system that we built. I wasn't there, but the computer system that IBM built beat the world champion, basically, right? Well, what if a system like that could then go and learn how to do romance, right? Or like learn how to raise a child or whatever, right? But that's not the case right now. You could never ask an artificial intelligence system that searches through your photos on Google to then go like babysit your baby, right? That's just not something that is going to do. So that's general AI. When we have something like Ex Machina, where it can walk around and talk to us and do different things and have its own opinions on stuff and say, no, I'm not going to do that. Its own agency, right? Narrow AI is what we just described. Narrow AI is really any machine learning algorithm that we have today that does anything. Self-driving cars, computer vision, transcribing speech to text, data analysis. These are what's called narrow AI. Now, some people in the field want to retire that term, but I don't. I'm going to keep beating that dead horse because I think that's a very relevant distinction. We are very far in terms of capability, if not time. It's hard to tell where the inflection point will happen, but we're very far from general AI, and we are, narrow AI is where we're at right now. But there's a huge chasm between those two principles combining. And there are efforts to help get there, right? I mean, you guys have probably heard of Elon Musk's Universe AI system. I think it's awesome. Basically, it's like a BYO AI thing where you can say, hey, I just trained a machine learning algorithm using TensorFlow or whatever, and I'm importing it into this Universe AI thing. And what the interface does is it forces the UI to interact with the computer system the way that you or I do in terms of mouse clicks and looking at pixels on a screen. So there's a couple of examples where it can play Pac-Man, it can play different first-person shooters, and it can go from, and it's to help you train the AI to do different things, multiple things, hopefully getting to general AI. I think that's really cool. So it could happen sooner or later, but they're not at all the same thing. So deep learning. Deep learning is a neural network training technique that has been further reduced in complexity and made more available to more people both inside and outside of the data science community, by open source efforts like TensorFlow and Caffe and other things like that, and CUDA, graphics, NVIDIA's GPU accelerated options, et cetera. But it's important to note that those are libraries, helper libraries, that help people train their own neural networks using deep learning and unsupervised learning techniques. They're not Google or anyone else, for that matter, giving away their secret sauce as to how they train their amazing machine learning algorithms. Okay, so that's another distinction that I think comes up a lot when people ask me about Watson. Oh, what about Watson versus this or Watson versus that? We'll get into the difference after that, or in just a minute. So machine learning is these. So have you guys heard of machine learning algorithms? Yeah? Okay, I'm assuming everybody has. So you train machine learning algorithms using deep learning techniques and unsupervised learning and stuff like that, right? Cognitive is sort of a more general term that has started to become used in some circles to refer to artificial intelligence. So you can think of it as an umbrella term that could encompass all of these things, or one or two or five of them. And then machine learning as a service, artificial intelligence as a service. I mean, that's sort of self-explanatory, I think. And there's a lot more, but I think that, you know, if you could have one takeaway from this, it's that the tools which enable people to train machine learning algorithms are not the same thing as the machine learning algorithms. So, sorry, if you could take away two things. And machine learning algorithms are narrow AI, not general AI. Okay, I'm done with my little OCD rant. Current approaches to AI. So because this was an invited talk, I want to keep it somewhat general. I will touch on IBM stuff. I'm trying not to be too like, hey, check this out. So there's a few different approaches that I've noticed. What we have, what Microsoft has, what other folks have, which is a cloud-based approach. And that means we have our own. So we have something called the Watson Developer Cloud. And Microsoft has, I think, like cognitive services. And basically, there are a bunch of machine learning algorithms that they and we train on our side. We then host them in servers all over the world. And we, the endpoint for a developer is a REST API call. It's a simple call. You say, hey, I want to pass this to the Watson speech-to-text service so that it transcribes what I say into text. And then it does that and sends you a JSON file back. So you don't actually see any of this machine learning stuff. But the trade-off is you get really short time to value for advanced functionality that would take you forever to build your own locally hosted and trained using the things we just talked about, machine learning algorithms. So for a lot of people who have internet-connected applications, games, services, et cetera, cloud platforms are, for obvious reasons, a very quick way to bootstrap and shortcut the time to value and time to advanced functionality. Local algorithms, TensorFlow, Caffe, CUDA. This is where you take a machine and you say, OK, machine, use all of your processing power and the GPU on board and use this software to run 1 trillion tests on this thing and train me up a machine learning algorithm using whatever technique you prefer. And the benefit of that is you don't need an internet connection. You own the algorithm that you train. And you can put it on board, embedded into an application or a system like a small Raspberry Pi type of thing that can only phone home every so often. So if you don't have some examples that I've heard are like NASA doing a targeted keyword recognition system for rockets. Well, obviously, you don't have reliable internet in space, so if they were to use Watson, might not be the best use case. So it needed to be local and onboard. And it could be simple, right? They don't have to have the best user interaction where you can just say, hey, NASA shuttle, get me a latte, right? No, it's more like launch missile. Probably not that, but something like that. Sorry. I don't know why that came to mind. That's actually kind of dark. Whatever. Like, turn up the heat. I don't know. Eject the waste? I'm done. So open source. Open source is actually something I'm really high on for machine learning algorithms. There are some companies doing really cool stuff, and I like the model. So basically, you're the governing body, right, for machine learning algorithms that you put out there. You say, hey, we're H2O.ai. We have this amazing visual recognition machine learning algorithm, and you can use it. It's free. But we also have these amazing solution services around it. So if you wanted to do this advanced functionality, we could help you, and it would only take this long and just this much money. So they build their business around the services, and obviously, they're always the ones that are knowing what the latest and the greatest things are with their open source machine learning algorithms. And everybody else that uses them, should they do the best job and have the best engineers that are committing code, they will be just a step behind them. So I really like that, but it remains to be seen how it plays out, because the big players are up at the top, mostly. And the small, scrappy startups are either at the bottom or getting gobbled up by the big players and getting merged into their strategy. So I'd like to see some of these companies continue, persist independently, and put some pressure on the industry because open is good. All right, so AI in VR 2017, current usage examples. All right, so I'm going to go through these basically in 3 buckets, sort of like low-hanging fruit, some other use cases, and then really kind of random stuff that people think is great, but I have some opinions on that. Won't go over that. So first, I'll do a shameless plug. So interactive speech interfaces is what I've been working on, as I mentioned, with the IBM Speech Sandbox. So we built this demo for HTC Vive using our Unity SDK for Watson, and we used 2 IBM Watson services to train essentially a full natural language command and control interface demo. It's a tech demo for developers. It is available in Viveport. We launched it at CES in partnership with HTC. So if you have an HTC Vive, you can download that. We also have other builds. We're going to open source the first 2 builds. The first one is obviously HTC Vive, but we also have a Google Daydream build that we want to make open source. And then we want to do other builds for maybe Oculus if it's worth it. I mean, it's not that vastly different for most of you guys, at least within Unity, to swap out the camera rig, but it might be worth it just to have a ready-made solution for developers and other things in the future as well. So this is not the final title. That was what it used to be called. I'll just play a brief video describing sort of what it does. And keep in mind, this is meant to be an idea starter for developers, and there's an accompanying how-to guide which teaches people how to build their own version of this.
Welcome to the Sandbox, powered by the Watson SDK for Unity. Today you'll discover how to manipulate your virtual world with voice.
So basically, you can create anything you can say. There's about 200 objects in the world. You can point anywhere and you can say, like, create me a large black dinosaur.
Out here you can create a large number of objects and see how they interact with each other. If you need some suggestions on what you can create, just ask, what can I create? And I'll tell you some of my favorites.
But the point is really to show...
Create a big gorilla.
OK, there you go. So she said create a big gorilla, but we only have large, medium, and small.
Create a small gorilla.
That was a correct entry. The first one wasn't. But that highlights the automatic error handling server side using what we're calling the Watson Conversation Service. So it will match the intent of what a user says to the action that they want to take. So in this case, if you say like huge, massive, big, it will know that the intent is large, so it will scale it up accordingly. Same thing with small. And then there's other objects that you can skin in terms of color. So you can say, like, create a big black dinosaur, a big blue dinosaur, a tiny green truck, whatever. And it will parse out and swap out actually yeah, it's kind of fun. Swap out the texture for the right color. And we did this to sort of highlight that it's not just all about chatbots. So if you use Watson Speech to Text, you get some stuff like it's always streaming data to the service, but very small packets. So it's like 8 kilobytes. And so you don't have to use a wait word. You can just say, create a rocket launcher, for example. And then with so speech to text, and then with the conversation service, it takes the transcript. Yeah. The lead developer just needed his guns in the game, so I didn't fight that battle. Just wanted the audio interaction. Perfect, that's it. Yeah, so feel free to try it out. I think that Google Daydream build is actually more succinct, so I can't wait till we can get that out. We're hoping for the end of April. And the second thing was just really, it's non-trivial to create a system that does automatic error handling like that on the back end. Like, we didn't hard code any of the queries except for the ones that are exactly correct. Everything else is error handling by the Watson Conversation Service on the server side. And so that's enough about that. If you're interested, the link to the how-to guide is here. It's ibm.biz/Watson_VR. And that's secretly my ulterior motive for being here. I want to get developers interested in the fact that we have a ready-made solution that's scalable because it's a cloud platform and pretty darn easy to integrate right here. And it's not just for command and control. You can think about productivity use cases, like what if you're doing Autodesk or Tilt Brush and you just want to say, give me the brush I had 3 brushes ago, make it 2 points smaller and blue. Right? And it just pops in your hand. You could literally do that with this system with very little modification. Then there's other more simple stuff like training and stuff like that, where maybe your hand's occupied if you're doing a surgery training or you're pitching against a professional pitcher using Moneyball type data, and you want to just say, play that back, or give me a different pitcher, play it back in slow motion, or show me the numbers, or whatever. It's almost necessary in many emerging use cases. So I'm very high on interactive speech in virtual reality. And by the way, every single VR headset has a microphone. What do you know? OK, visual recognition in VR is interesting. Do I have time? Let me see. OK, I have a little more time. So actually, one of the first things I did with SVVR, Silicon Valley VR, is a hackathon at their old headquarters. And the winning team did something very interesting. I wanted to do this as an experiment of how out there could we get it and still have something of actual potential use come through it. So this team, Watson and Waffled, made up of gaming industry vets, came up with a use for one feature of our visual recognition tool, Watson Visual Recognition, which is you can actually retrain it to recognize things that it's kind of not supposed to out of the box. In this case, they did it for user-drawn, kind of Scribblenauts style images that it then, or symbols that it submits to the system. And you can easily train a system to recognize those. And so in this case, you'll see that he can draw.
As an item, we're having problems getting the ladder mesh to spawn, but we do have what works. The key works. So I can draw a key, and it will detect it in.
And this happened in a day, by the way. That's what's kind of fun.
Then maybe grab if I'm
So this whole thing was built in a day, and the difference between a gesture recognition system and this is that this allows a user to complete a drawing and then manually submit it before the system considers whether or not it's something, right? Versus gestures where it's whenever you do something.
And can get past.
So you can go back and touch up your house. Oh yeah, this gets weird.
You can go to this door which is locked and it needs a key. And
I don't know why there are weird masked people dancing around in this dungeon, but you can check out the demo, Watson and Waffles. There's a Windows build, apparently, that they released, if you're really interested. I'm sure it's the only Watson and Waffles
turn it
on
or off.
Ooh, maybe I can end this talk when my battery runs out. All right. So data manipulation is something I've heard a lot about, especially in relation to Watson. Everybody thinks that Watson is magically going to spit out data insights. It's not magical. There are some services that do it. But I would say that the most salient thing that I've seen in terms of data insights in virtual reality and even augmented reality is spatial recognition of anomalies. So it's very real and prescient that versus a 2D chart or graph or even faux 3D on a 2D screen, right? Your mind actually is better with spatial data at picking out anomalies in data. And I'd like to see more work on that. That's not to say that it's going to magically be served up for a user, but there's a business there if there's a middleware tool that will do that. Essentially Jupyter Notebooks or some other open source thing for virtual reality and automatically giving you these amazing next level visual insights you can't get outside of VR or outside of the metaverse. OK, I've always wanted to say that. Can't buy in the house? No? Nobody? OK. OK, so these are some other out there stuff. I've seen a lot of attempts for people to replace the functionality of traditional game AIs. It's important to note that they're not at all the same thing. Game AIs actually, generally speaking yet, to date, don't use advanced machine learning algorithms. They use very simple gating systems, almost like a very advanced Excel sheet for the behavior of the non-player characters, in the games. Data manipulation we talked about. Chatbots, there's already a game out that I really want to try called Event Zero. I felt so bad reading their blog, though, because they said they spent 8 years working on getting this functionality absolutely correct. But they hard-coded everything. So it's just so much wasted effort. But I'm sure it's good. But I'm sure that anyone in this room could actually rebuild something just as robust now because of all the platforms available in the next 6 months. But the art style of the game looks great, and I can't wait to see it. So I'd actually like to see more realistic, story-based games wherein you interact with your voice with non-player humans, aliens, whatever, robots, in virtual reality and augmented reality. And of course, I'd also like to see more with education, training, therapy, and recovery use cases for AI in VR. I think there's a lot of greenfields there. In the future, I think I'm out of time. I'm sorry, guys. We'll have to. I'll give you one. OK, so let's see. I think that obviously there's a possibility for you guys know when like we were coming of age, and our parents were like, "What are these newfangled cell phones you're doing?" When I was all this kind of thing, we kind of rolled our eyes and were like, "Oh my gosh, our parents." I actually think that's going to be way worse for us. Even us in this room, who are all in on VR and AR, right? Like our kids are going to grow up in a merged world where reality and unreality are all reality, right? And so they're going to understand this in a native way that we probably never will, although I'm holding out hope that with advances in medical science, we can somehow augment our cognition and persist. There you go. That's my trippy nugget. If you guys want to reach out to me, this is my info. I guess I don't have time for Q&A. It's 2:25. I want to make sure the next speaker has time to come up, but I'll be around the rest of today, and I'd love to chat with you guys. Thanks a lot.